Alright, today we are going to look at the topic projectile in physics. Now when we talk about projectile, we said it's when a body is given an initial velocity and move freely under gravity. Now let us look at this diagram here and let's see how we can use it to derive some equations for projectile. Now let us consider a body at point O, which is given an initial velocity u, all right, and the body move in a parabolic manner, as we can see. Now as the body moves, we can resolve its initial velocity in the vertical direction, and we can also resolve it in the horizontal direction. Now if we take the initial velocity in the vertical direction as uy and the initial velocity on the horizontal direction as ux, what can we say? Now we can say that in resolving the vertical and the horizontal, let us consider this and see what we can do here. So this is the movement of the body with an initial velocity u, all right, and the body move in a horizontal direction with an initial velocity ux, and this is the vertical direction with an initial velocity uy, all right, and the angle of projection is given as alpha. Now let us look at the horizontal motion of the particle. All right, the horizontal motion of the particle. Now, how can we resolve the horizontal motion with respect to the initial velocity, as you can see here? Now, in this case, we are going to consider the initial velocity, then we also consider the initial velocity in which the body is moving. And this is going to be adjacent to this angle, and this will be hypotenuse. So adjacent hypotenuse, we are going to use our cos ratio. So we say cos alpha equal to adjacent, which is ux over u, all right. Therefore our ux will be u cos alpha. So this is the initial velocity, all right, of the horizontal motion of the particles. Let us also look at the vertical motion, all right. That is the initial velocity on the vertical motion, which is this side, uy. All right, what can we do now? Now uy is opposite to this angle, all right, and this is hypotenuse. So opposite hypotenuse, we use our sine ratio. So we say sine alpha equal to opposite, which is uy, all over what? U. So we can say that uy is equal to u sine what? Alpha. So this is the initial velocity of the body moving in a vertical direction. All right, let us look at these formulas from linear motion, where we have v equal to u plus at, then we have v squared equal to u squared plus 2ax. We have x equal to ut plus half at squared. Now let us look at something here now. Now when we want to treat this in a vertically upward direction, it means that the body is moving against gravity. So since the body is moving against gravity, our acceleration will be equal to negative g, as we can see here. So anywhere we see acceleration, we'll put negative g in there. So let us look at this formulas here, how we can deduce another formula from it. So we are going to have v equal to u minus gt, all right? Then we also have u squared equal to, v squared equal to u squared minus 2gx. We also have x equal to ut minus half gt squared, as we can see from these formulas. Now, one thing we need to know is that at the maximum height here, our final velocity is equal to what? 0. That is the final velocity on the vertical axis or on the vertical motion direction. So we can say Vy, or we can say V equal to what? 0. So let us see what we can do. Now again, since we analyze this, let's come here. Now if the initial velocity, which is u, is given as u sine alpha, then we can rewrite these formulas as v equal to u sine alpha minus gt. All right, then again, that is v squared equal to u sine alpha squared minus 2g. All right, h, the distance here can be represented by the height, or we can even use y to replace it here, so don't forget about that. And again, our h or x or y will be equal to u sine alpha multiplying time minus half gt, all right, gt squared. So we can have these formulas here for projectile, but we stated already that at the maximum height, final velocity is 0. So let us pick this, all right, and see what we can deduce. So if final velocity is 0, from this equation here, we can say 0 equal to u sine alpha minus gt. All right, we want to make t the subject, so we can say that gt equal to u sine alpha, divide here by g, here by g. All right, so t will be equal to u sine alpha all over what? G. And this is the formula we use for time taken to reach the maximum height. All right, time taken to reach the maximum height, time taken to reach the maximum height. All right, time taken to reach the maximum height is given as this. All right, let us look at this equation as well. All right, if v at the maximum height, v equal to 0, so we can say 0 squared is 0, so we have 0 equal to, let us expand this, all right, because we have u sine alpha all squared. So expanding this, we are going to have u squared sine squared alpha, all right, minus 2gh, as we can see. We want to make h the subject, therefore I have 2gh equal to u squared sine squared alpha. All right, so divide here by 2g, here by what? 2g. This will cancel this, so my h will be equal to u squared sine square alpha all over what? 2g. And we say this is the formula for calculating the maximum height reached by the particle. The maximum height reached by the particle. So this is the formula for it. Now let us look at what we call time of flight. Time of flight. All right, and when we say time of flight, that is the total time for the body to move from, that is O up to A. All right, and the time of flight will be 2 times the time taken to reach the maximum height, which is u sine alpha, all right, all over what? G. So the time of flight is going to be 2u sine alpha all over what? G. So this is the formula for calculating time taken to reach the maximum height. Let us look at the range, all right? The range, when we say range is equivalent to the horizontal distance traveled by the body. The horizontal distance traveled by the body, we can say x, which is equal to initial velocity times time, all right? But for the horizontal distance, the initial velocity is given as u cos alpha. So we have, that is u cos alpha, all right, multiplying time, as you can see. But from here, time of flight, our time is equal to 2u sine alpha over what? Over g, as we can see here. So anywhere we see t, we are going to put, this is u cos alpha, multiplying our time here, which is 2u sine alpha all over what? G. So we are going to multiply this. U will multiply this. We are going to get u squared. All right. 2 cos alpha. All right. Times sine alpha all over what? G. And from trigonometry, anytime we have 2 cos alpha times sine alpha, it will be equal to sine 2 alpha. So we need to know this from trigonometry, all right? So here we can say that u squared sine 2 alpha all over what? G. So we say this is the range formula, all right? This is the range formula, which is u squared sine 2 alpha all over what? G. So these are some few formulas that we can use to do our calculations under projectile. Practice it and make sure that you understand it well. Anytime they give you question, you use any of them. Thank you.